It's Pi Day, so I'm going to do a Pi Day thing. And I've done this before, but I want to work through it live code. Everyone likes it when I do live code. I want to do a one-dimensional random walk and show that the average distance depends on the number of steps in pi. So I'm gonna do this whole thing, and then after that, if I have time, I'll make a 3D random walk because it looks cool. The end. Okay, so let's jump over to Python now. I'm handicapping myself because I'm not using real Python. Some of these things would be easier than real Python. You know, I'm a WebVPython kind of person, so I'm using WebVPython. Let's start off and make just a one-dimensional random walk that we can visualize. That's the important thing. And then once we do that, we can kind of make it into some functions and do a bunch of stuff because we got a bunch of calculations to do. And so let's just do this in 1D because I know the equation for 1D, and then I'll show you the 3D. Okay. So here we are, WebVPython. I'm going to give you the code. You know that. You know that. No. We're going to give you the code. Let's just make an object I'm going to move around. I want to show that. And I want to make a step size. So let's say my step size is 1. Who cares? And then B is my object. It's a sphere, and I'm going to start it at the origin, vector 0, 0, 0. The radius, let's give it a radius, not a radius. A radius of 0.1. Let's make it yellow. And let's turn on a trail. Make trail equals true. Okay, let's just run it. That won't do anything, but just to make sure. I don't know why. Okay, there's my ball. Okay, now what I want to do is to make a counter. I'm going to move it, let's say, n times. So let's call this n temp. Let's just call it n. N equals 0. I want to move it 10 times. N equals 10. This is the way I like to count things. And there are different ways. You count your way. You do it. I just like it this way. While n is less than n, do the following. And then the first thing I like to do, n equals n plus 1. So if you don't do that, you get an infinite loop, and it's just awkward, and you feel embarrassed. You're like, I don't know what I'm doing, so do that. Now what I want to do is to generate a random number. In WebVPython, I don't have a lot of options. Rn equals random. So that's going to give me a number between 0 and 1. So what I'm going to do is if that number is 0.5, less than or equal to 0.5, move to the right. If it's otherwise, move to the left. And it's not perfect, but it'll be fine. So if Rn is less than or equal to 0.5, then, oops, I messed up. Then let's say dr, that's my step size, dr. dr will be the vector. I'm going to do this in vector because that way when I go to 3D, it's the same thing. Will be s0, 0. Otherwise, else, dr is vector negative s0, 0. Now, if I run this, it'll do it. It won't even make any sense, but I'll do it. I'll show you why. Let's just run this. It didn't do anything. It didn't move. Okay, well, that's because I didn't let it take the time to actually show the moves. So I can slow this down with something like rate 4. This will only do 4 moves per second. 4 loops per second. And it still didn't move. Oh, I didn't move the ball. That's why. Okay, so I have dr. Now I need to move the ball. b.pos equals b.pos plus dr. That's why. There. Now it's moving back and forth. Random walk in 1 dimension. Not super exciting, but there it is. Okay. So it looks like my random walk's working. I can then, I could do 100 and make this, let's say, 50. And so it's moving back and forth. You can see it moving back and forth. But I don't want to do that. I don't want to do this. If I want to make a plot of the average distance, I need to run it a bunch of times, right? So let's just not display it. So instead, I don't want to display this. I'm going to comment out that I don't want to display anything. I don't need these either. I don't need that. I do want to do this, but I want to do it in a loop. So let's make it a function. And I'll call this walk. And I want to pass it in. So this says I'm going to make a function where I give it a number and it's going to do that many steps. And it's going to return the distance. And it's not going to give the average. Okay. So I want to do all the stuff in here, I'm going to, oops, what did I do? No, I want to tab all this. So highlight that, tab. Okay, now I want to put things in there like S equals 1, R equals vector 0. R is going to be my position. I'm not going to actually draw it. S equals 1, 1. And let's say NT for temp equals 0. So now I just need to change this as NT. I don't want to do a rate statement in there. RN is fine, DR is fine, and this is just going to be R. R, and that's NT, NT. And then when I'm done with that, I want to return how far it went. So I want the number of how far it went, the magnitude. And it could be, it's in one dimension, so it doesn't really matter, but I did it as a vector. So I'm going to return the magnitude of R. So let's just try this out. Print, what did I call it? Walk. Let's do 100 steps. Let's see how far it gets in 100 steps. Let's just see if that works. I haven't even saved this. 12. Play it again. 0. Oh. 4. Okay, so it's always going to end up with a positive, with a positive integer number, right? Because I'm doing integer steps. So it's going to end up a certain distance away. That's just the way it is. Let's save this code before I forget. Random walk pi. And you can't see it because I have that. Oh, I did that. Okay, I'll give you the code down below. Okay, so I have that function. Now what I want to do is to run that function many times to get an average. I'm going to call this make another function called daverage. So I don't want that. Daverage. And I'm going to pass to it how many steps I want. So let's call this ns. And let's put a note here. Returns the average distance for ns steps. So what I want to do is to run it a bunch of times. I'm going to pick 500. Let's say average over 500. So I'm going to do it 500 times and average it. So to do that, I need a total distance, and then I need to divide that by 500. So I'm going to run it 500 times, add it to a total. So let's call this total equals 0, and then I need to a counter in. I used nt before. Let's use ns. ns equals 0 while ns is less than ns. That's kind of fun. Do the following. Number 1, I only need to do one thing. Add the average distance to the total. So total equals total plus. Now here's where I use that of the function. I just run this function walk in. Walk ns. Is that right? No, this should be 500. Right. Walk ns. So I'm going to run the function and add it to the total. And now I need to add 1 to ns. ns equals ns plus 1. And that's it. And then I can return the average, which is going to be the total divided by 500. And let's see if that works. Print daverage for 10 steps. So what's the average distance if I take 10 steps? If this number is greater than 10, I messed up, right? Because it can't be further away than 10. And it's not, because I got an error. Can't find variable daverage. Def. Sorry. Okay, 2.14416, 2.56, okay, so I think it's working. So now I have two functions, and I can use those two functions to make a graph. Let's just make a graph of the average distance as a function of step size. And these are for 500 steps. Okay, so over here at the very top, I'm going to make a graph. G1 equals graph. Let's give it a title. 1D rando. I like rando walk. Rando. X title is going to be equal to n steps. Y title is average distance. And then let's give it a width of 400, height of 200. Now I'm going to go ahead and plot points. And so I don't want to make a curve. So let's make F1 G dot. So let's just plot the dots. And color equals color dot blue. So now we can do some magic up here. Now I'm going to just say, I think I can say n equals 0. And I want to go up to n max of, let's say, 300. And I don't want to do each step, and that's fine. But let's just say while n is less than n max. What am I going to do? I'm going to calculate the average distance for that and plot it. But I can do that all in one step. F1.plot n, and then the name of my function was daverage n, right? And that's going to plot it. That's going to give me, it's going to do it and plot it all together. And then I would need to add 1 to my n equals n plus, I could do 1, but I don't want to do 300 steps. Let's just do every fifth number. I don't want to do them all. Okay, let's see if that does indeed work. Loading. Okay, so it's a lot of calculations. It's not going to do it instantaneously. But remember, here, let's switch back to a second. We're trying to plot this, right? So this says d should be proportional to the square root of n. I could write this as d average squared equals 2 over pi n. So if I plot the average distance squared versus n, the slope should be 2 over pi. Okay. Now, it's WebVPython. Okay, so I'm not gonna actually do that. Instead, let's go up here. I'm going to change my graph title. My X title is fine. Y title is going to be squared. And then down here, I'm going to plot d average squared. And it should be linear. Again, it takes a lot of time. I should have. That looks pretty nice. I'm not just in. So right here, I'm not sure. You know, there's some random stuff going on there, so that's fine. Now, what you could do is define the slope of this line in WebVPython, not built in, so I'm not going to do it. But you could take this. Look, it goes through 0, 0. So I could take this point up here, and that is 188. 191 divided by 291 and see if that is equal to 2 over pi. So let's just print that out. What did I say? 191, 291. 191, so this is down here. Print 191 divided by 291. And I'm going to say this is equal to calc pi. Calc pi, this is actually 2 over pi. Calc 2 over pi equals. And then let's say print 2 over pi equals 2 divided by pi. And so I'm not using the data. Again, it's taking a long time. Pretty close. Pretty close. I'm pretty happy. Okay. Now, let's make a 3D random walk because it's fun. And this is technically a lattice, not a self-avoiding walk. So there is a walk where it avoids crossing its own path. I'm going to let it cross. Actually, I'm going to do 2D and then convert it to 3D. So let's save this and just make a new program. Save that one. I'm going to give you both codes. The other one's more fun anyway. Okay. I'm going to go ahead and copy some stuff. I'm going to copy this stuff right here. Right there. And then I'm going to make a new code. Let's just do it right here. Click, 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 click. Okay, click. And then I want to dedent this stuff. Okay. I don't need R. NT is fine. Okay. B equals sphere. position equals vector 0, 0, 0. Radius equals 0.1. Color equals color.yellow. Make trail equals true. Okay. Now, this should work for the 2D. I've already got nt is 0. I don't have n. Let's say n equals 10. I'll put my rate statement back in here. Rate, let's put 10. We can play around with that. Random, that's fine, that's fine, that's fine. And this is just going to be b.pos. b.pos. And it should work. This should be the 1D. Okay. So now to do 2D, I'm going to use the same random number, but now I want to make 4 choices. Positive x, positive y, negative x, negative y. So let's do if this is less than 2.25, then that's true. And then I'll do this. If Rn is greater than 0.25 and Rn is less than or equal to 0.5, then go in the positive. I'm going to just do this clockwise. Yes. And I'm doing a 2D. This is 2D. If Rn is greater than 0.5 and, or I'm going to put greater than or equal to. No, just greater than. And Rn less than or equal to 0.75, then I'll go in the negative x. Dr equals vector negative s0, 0. And then finally, if, I'm going to do this as an if statement, if Rn is greater than 0.75, then dr equals vector 0, negative s0. Okay, and then everything should be fine. This is going to do just 10 steps. If this works, then we'll do as many as we want. And it didn't. If Rn must include a colon. Okay, that's easy to fix. Colons. I didn't. If. Just that one. Okay. Let's save this because I didn't save it. 3D random walk. Run it. Oh, I didn't save. I did save. Okay, run it. There we go. Okay, that was pretty good. Let's do if we can do 10, let's do 100. But let's make this a little bit faster, 30. Otherwise we'll get bored. I kind of want the point to be bigger, but I think it's good. I'm pretty happy. And that looks kind of cool. So, and this is technically in 3D. It's just only doing it in 2D. Okay. So now I need to split it into 8 pieces, right? So let's say drn equals 1 divided by 8. Yeah. Okay. So if this is less than drn, then move in the positive x direction. And then I need to do all these by 8th. So this is going to be, so this is going to be 2. No. This is drn, and this is going to be 2. 2 times drn. This is going to be 2 times drn. I did this a different way before. 3 times drn. This is going to be 3 times drn, and rn less than or equal to 4 times drn. Okay, so now I'm going to do it in the z direction. I need to redo this whole thing. It seems like a lot of work, but okay. Let's just copy all this. Let's see if that works. Okay, so I did 4, so this should be 4. And this is going to be 5. And then I'm going to move in the z direction. No, I need 6. There's 6 directions. That's fine. I can fix this because fortunately up here I did this by 8. Okay. And then I said 5 right here. And this will be 6. And then this will be negative s. And is that it? Oh, this is 0. Okay, let's just try it. I don't know. Okay, I did it. Look at that. I'm pretty happy. Zoom in, zoom out. You can do as many as you want. And this is a lattice walk. Okay, so that's 2 codes for Pi Day. Hope you enjoyed that. That was fun. The end. There's a bunch of stuff you can do with random walks, but and we're limited in our curve fitting in WebVPython, but we're not limited in our 3D stuff. So that's awesome. You could do this technically in real Python, but it doesn't look as cool. I mean, come on, let's be honest. That's not as cool. Okay, that's it. The end. Happy Pi Day.